Yes. If you put start from putting 3, 3, 5, 7, 9 around that. So one you can do out of whatever it is, you can get some numbers, some 10 samples from 3, 7, 10, 3, 7, 11, right? 3, 7, 9, 11, 13, 7. Other way, this program can also be, you can do to find out the K.
Okay. Okay.
Yeah. So what is there? Ultimate intention to change the K value. So if there are 150 records or row is there, that means how many samples are there? 150.
150, right?
Might be column, maybe more than one. So that is the answer to talking about the rows. So out of 150, we'll be saying first, then we will be saying the second, third. So if we go on continue, that means K value is up to that limit we can do.
Do, yes, right.
So out of that, which one is the base sample? Okay, so I was just okay. So I try to reproduce here in this one example.
Okay.
For that, I took a data set of iris. Iris is a flower data set.
Right.
Already aware of it. Okay. So flower data sets that is already present in the SQL data sets.
Data sets. Okay.
So looking at just I was doing that because I wanted to show you. I don't wanted to waste time. It was not their example. So if you see, this is what is there? Data target as like other one example. Data then target names. So it has three different types. Set to the versicolor and
Virginica.
Iris, yeah. Veronica or something, right?
Yeah.
So, and there are features are how much? 4 features only. Sepal length, sepal width, petal length, petal width. That is the small leaf and the long leaf one. So 2 times are there. Here. So if you see in this image, more time. So this is petal length and petal width.
Right.
And sepal length and sepal width.
Yes.
So that is the 4 features. So PD the data frame, iris the data, that iris is the dictionary format itself. So if you load it, then you will get to know that this data is like this. So 4 features, 4 columns represents 4 features.
Right.
And the columns, you can in the data frame columns you can save in the features name. That is sepal and sepal width, petal and petal width.
Right.
And there is a target also it's specified in iris the target that we can include in the data given a new name.
Right.
So that indicates 3 different type with 0, 1 and 2. I mean they represent in 3 numbers. If it is not there, we could have converted into using hot encoding. Right? If it is a name was given, so we can convert into correct hot encoding. Using hot encoding, you can convert it, right?
Right.
So this is the target. Then I put X and Y from there, which is a target, and then we split the data.
Right.
And then first we will here it is doing on the K nearest neighbors like yesterday.
Right.
Using 3 neighbors, and then we get the accuracy this one. Now the thing is, now the thing is how we can do our. I mean, we can do find the base K. So it's taking 1 to 50 samples.
Samples.
Let's say it takes 50 samples. and our data might be more there. So I think it's more dot shape if I put 150 sample, right? So you can put 150 also, it's okay. So list of range of 1 to 50 means create a range of from 1 to 50 list of elements, and this is this my list. So it's a list of 50 elements. And setting just the odd ones. This is the methods to do x and x out of x mod. I mean finding the odd ones 1, 3, 5. Lambda is a function, actually one line function, a little bit complicated function. So introduced in all the languages. So using that, so we can reduce in one step some callback kind of things we can do, and we create a method and get the return in the same step.
Okay.
So it's kind of a callback already implemented. That is x mod 2 not equal to 0. That will convert in my list.
Nice. Okay.
So that means 1, 3, 5, 7, 9, right?
Yeah,
All
those
these
kind of
values
numbers.
come. Yeah.
Yes, sir.
Then they created a empty list.
Right.
And for k in neighbors, this one, knn is equal to k nearest classifier neighbors is equal to
K.
n underscore neighbors is equal to k.
K.
So n underscore neighbors is total number of, that is the already inbuilt. So n, this is a name, you cannot change it, right? So
Right.
k is a value. So this is hardcore. I mean, this is the parameter expected by this method.
Right.
So now what we did, we use the KNN method using many out of 50, or I say 150 because we have 150 samples. And then we put a k n equal to k. So it will, every time it will go and neighbors objects will create. And then we are trying to get cross validation score.
Right.
So cross validation score is not defined. So I need to put a header for that.
For the triangle. So you have to find the module which has it, right?
Pardon?
So you have to find the module which has a cross-val score, right?
Ah, yes, yes. We are gonna make it clearer by performing a 10-fold cross validation on our data set using a generic list of k. So cross validation is this is a same only. One you are using that splitting method, right?
Right.
So this is a k-fold cross validation. This we are going to implement.
Right.
So like this, you can check and get all the headers, whatever you want.
Right.
From this link, you will get things with example.
Yes.
So just like I don't need to, I mean, it's not possible also everything to remember. So then cross validation score and then mean of that score.
Right.
So expected neighbors less than is equal to samples.
Samples, okay.
Okay. N minus 1 I have to put, I think. So n samples is equal to 88, n neighbors is equal to 89.
9. So you have to put like n neighbors minus 1.
N neighbors
Minus 1.
here the neighbors. Here this filter is doing here.
Actually, your neighbor's spelling is different. Yeah,
Got it.
and now it's good.
Unsuperable type minus filter and int. Neighbors is 89 and sample is 88.
It is still
The three is different. Once again, expected n neighbors is equal to n samples. And here it got cross validation scores. Every time it gets scores, it is appending, right?
yes.
Scores dot mean
Mm-hmm.
cross validation scores and taking the mean value every time
Right.
and get it in CV scores. And then ultimately takes mean
MSc, yes.
MSE. So MSE is 1 minus x for x in CV scores.
Mm-hmm.
That is this comprehension it's called. If you put it like this, 1 minus then x for x in CV scores.
Mm-hmm.
So CV scores is how much? Let me print out here. So this is many values are there. Right?
Yes, yes, yes.
CV scores dot appends scores dot mean.
So it is score 1 minus 0.94 for the first row, right?
So here it will do x in CV scores, all the value will take and 1 minus that.
X, yes.
So that is the error. This is the accuracy.
Mm-hmm.
So here it will go. Here it will go the accuracy, and here it will go the
Error.
error. So then optimal k determining the base k neighbors MSE dot index minimum of MSE. The minimum value of that. This is obviously right. The minimum of this whatever is there out of all
Mm-hmm.
this.
Mm-hmm.
Now if I put this one,
Mm-hmm.
Right? This is converted.
Converted, yes.
And then optimal K is to stay. MSE of index, minimum of MSE, this one.
Mm-hmm.
So that will give you only the neighbors of the minimum optimal K. Sorry. So that is in 3 version you have to put a bracket, and 2 version you don't
Yes.
require a bracket.
Bracket, right.
Okay, so you cannot print out that. So why it's not able to print out once again?
Mm-hmm.
Uh,
Maybe put the bracket just before the quotes, before and after the quotes, yeah. Or put comma after that.
once again, this is a wrong syntax, I think, for 3 version.
Yeah.
Comma 1 by we not required once again required.
Okay. No.
Object filter object is not
It's
subscriptable.
subscriptable.
One second. Hello? Yeah, I'm in some meeting. Can I call you? Who is there? I'm in some training. Who is there? I'll call you back. Okay. Yeah, so there's optimal K here. It is causing some problem. That object is not subscriptable.
Sure.
But if I put this way, it should not give. I think it's not a value to be print by. But if it is not printable value, then here how it is.
Mm-hmm.
Optimal number of neighbors. So it's a percentage D only will come.
Right.
If I put something is wrong, if I put this one also, not working. Oh, here only is problem. Sorry, not the down. Here only is problem.
Okay.
The object is not because see this indication is there.
Mm-hmm.
In the bracket, this is bracket and this is for the. Something is wrong with the formula. Exactly same, right? So there is.
Yes.
MSE, I already put it as a empty list is not put it or what?
Mm-hmm.
MSE, this one might not be there.
That's good with everything, yes. No, same thing.
Minimum is an empty sequence. You can more or less. Let me check on this one.
Sure.
Yeah, this one things. There is. And MSC. Okay, okay. MSC is already there, right? Already here.
Yeah.
We can do this.
Right.
So MSC is already we created. Sorry, sorry.
Yes, yes.
So MSC index.
So the goal of this exercise is to find out what is the optimal number of neighbors we should use, right?
Oh yes. So ultimately, optimal k is optimal number of neighbors. So
Mm-hmm.
that is number of neighbors k, x level and y level. The plot is what neighbors versus MSE.
Let me see, right?
So MSE is whatever error we got. So in the vertical line,
Mm-hmm.
and according to the value neighbors.
Mm-hmm.
So k value is ultimately we are plotting k and misclassification error MSE. MSE already we calculated
Right.
and
So, like, when do we say that the model is good? When the MSC is higher or the MSC is lower?
MSE should be lower. So error should be
Okay.
low, right? Accuracy
Yeah,
should
yeah,
be high, right? So
yeah, yeah.
ultimately we are calculating which one is giving you the most accurate, most accuracy.
Most of it. Okay.
Ultimately, you
So,
are not doing manually putting all the k and
right, right.
you this one.
Yeah. So, yeah. Can you just go back to the graph for a second?
Yeah, yes, yes, yes.
Yeah, this one, this one. So
So
based on this, when you have neighbors like close to like 7 or 8, that is the most optimal one.
7. That is here. It is printing out
Right.
here. So here it is giving error. So what I'm doing, so plotting this one only.
Okay. Yeah, yeah.
So only then we can figure out after we'll check out later on. We're wasting time.
Mhm.
So I my mistake. I put it up instead of down.
What happened? Sorry, I missed it.
I put it actually after this one I should paste. So I put it this code I put it up.
Oh, okay.
So MSc optimal K is already there. So this is something error is going during the printing. But we have MSc already. We require only MSc. This is the value. The
Hello,
value
yes.
is giving something error. So I will check it out.
Mm-hmm.
Yeah. So right. So out of this value,
Mm-hmm.
if you go back again, so there was some. I will just go back again. So that data we split and we did accuracy. So here you are clear, right? So 0.98 is the accuracy. Then our question is we put 3 instead of we wanted instead of putting the random value. One you can also do it. You write a for loop using odd numbers and print out. If you say 1 to 50 odd numbers, all odd numbers against k, if you put it, then you will get directly and then see which one is good.
Good, yes.
So, and this is a other way, a smart way of doing. So, cross validation score, and we created like a sample of 50.
50, yes.
And here there was a confusion was there how much we can increase maybe. Uh, so when we do this, we are already looking for odd numbers. So it's something value 17. Okay. So ultimately, what we did here, we are creating a odd numbers, right? Because we know that k should not be very high, so we are not taking k 150.
Yes.
Around 1 to 70 out of that, again we do odd numbers from there in this variable, and we k neighbors, nearest neighbors, classifier we call and put a cross validation score.
Right.
So which k will? So what is the score? So score we got. Then we got that individual score is individual scores mean. So individual scores, if you wanted to see again, we can print out this.
Yeah. So one question, like in this CV scores, we are scoring the mean. So what is the purpose of storing the mean in this one?
That is scores will have scores will have many value. I think that is why I just printing out it.
Okay.
This is the scores. Every scores. So every score will have a lot of values.
Values, yeah. Got
And
it.
you take the mean of every time it handles.
Handles, okay,
Every k
got it.
value it gets. So it gets some I mean lot of values out of that, which are more or less same only.
Sure, okay, got it.
So every time it takes the mean and then append. That is CV score. Again, next run into it got a new one. Again, so it's appending it like this.
Right.
So I just printed out the last one of this one scores. Right? This is the last course will come because of the K will be finished. Right?
Yes.
And then you got cross validation scores mean out of this, and 1 minus this one is the error. Error in every step, every K. So out of that, we have to find out the graph. MSC is there. MSC is the mean squared error. Mean squared error of mean squared error is what in a linear regression. If you see, mean square error is the error of all. Like if I if I show you in this diagram, So every data has some error, right? In the step.
Yes.
So if I take the mean of all this error,
Mm-hmm.
then it's a mean squared error.
Right.
Mean of all this error for every samples.
Sample, right.
Deviation from the actual regression line.
Line, yes.
So in that case, this is one error. So in Kmeans algorithm, every k it gives a total. Every k, so it gets many error. So
Right.
we take a mean squared error of that.
That's right.
And then again next step. So for every steps we get a mean squared error different. Because we are taking a completely different new solution, right? Again k we change it.
Mm-hmm.
K we are changing it. So in case there is a confusion, you just say, and now at least you can keep it that this is the step you can.
Right.
So MSC is you don't require empty, correct? So
Mm-hmm.
here it is empty. Empty. Here we calculate it out.
Mm-hmm.
Cross validation score and 1 minus that we get a
Right.
in every neighbors minimum of mean square error.
Mm-hmm. Right.
So optimal k, this is optimal k. So this is not working at the moment. So ultimately mean square error we are getting.
Right.
And that is all against the neighbors, we are plotting the mean square error.
Right.
So
Right.
the graph only. So in this case also, if you see 7 or 8, only 7 is 3 and 7 I always found is going to work somehow. I don't know why it is
Okay.
always happens there only.
Yeah. Yeah, you can look at that error like later and fix it. That's fine.
Okay. That is I
Yeah.
fix yeah. So I just explain up to here. So it's okay. I will check it and then I will send it to file. Okay.
Yeah.
So this is two way. Or one you can play with the prime numbers.
Okay.
And always you can make sure that 3, 7, 11 are in that area only it will work.
Okay, got it.
And this is the iris dataset that day we did another. So if you want something, you can get in any one of this.
Okay.
Some other applications, this kind of food reviews analysis using KNN
Uh-huh.
and check out.
Okay.
Yeah. So I will start another topic now.
Okay, that's fine.
So slightly we will go now from supervised because K nearest neighbors and K means are like a K nearest family only.
Mm-hmm.
I mean, although this one is K means K nearest neighbors is a supervised learning and K means clustering is unsupervised.
Building.
Comes under the name of K means.
So, the one which we learned is like supervised, and what we are going to learn is unsupervised, right?
Yeah, now K means clustering. The internal is also different.
Mhm. I
And
think this is the first unsupervised thing which we are doing, right?
first, there are very less unsupervised method. There is a clustering method is one. PCA dimension reduction is one.
Mm-hmm.
So clustering is a type of unsupervised and it's a very popular algorithm and it works by finding groups. Clusters means groups.
Yes,
Similar
yes.
data should be formed in a one group.
Mm-hmm.
and there is a k numbers of clusters required. K means how many groups you wanted to form.
Okay.
So let's say this is the data, and we don't know which are the different data, but we know that ultimately we are interested in 3 groups. So we divided like the right one.
Okay.
Using the algorithm. And during that, you do by bringing the samples that are similar in one set.
Okay.
So news article clustering, even like a news are given and we don't know what kind of news it is. So if it is not given, then news can be a sports news. This text classification, how it works, like if a description is there of a PDF, I mean a news topic, and the target column is written, that's a sports news. Again, a big document is there and it's entertainment news. And the target column, it is written as entertainment. So whatever big it is, the document is, but we already know that the terminology included in that belongs to one type.
Yes.
But this one, but when we don't have the target in the same things, then we can say that is unsupervised learning.
Right.
Yeah. So here it is a data set one column is there. If I put a description here, so much of description, and I don't put, let's say in that individual row, I put like 1000 line contents or a part of that folder, a PDF file. So then I don't put in the target. Then how will you do? It has to find out what is that content, right? So that is a unsupervised learning on text. So that we can do in news. I will talk on this kind of examples. Right now, we don't need to, I mean, because we don't have the samples in front and there will be confusion between.
Okay.
Even image and other implementation is there. So let's see a basic example. So it's a height and weight. Based on height and weight, if you wanted to, manufacturing company, if you wanted to produce t-shirts, then there might be like two things. Company can make 3 t-shirts or 5 or 7, right? That will fit to the 1 billion people.
Right.
So you cannot create 1000 different types based on, because people are more. So then what? 3 types are required. So there might be a question that okay, we have to design shirts. So there people are having maybe the height and weight maybe 40 kilo to 4 inch to 6.5 inch, 7 inch to 130 kilo.
Right.
So then company is interested in creating 5, not more than that, different types. So it will go to access from to Excel to access, right? So 5 types of data. So let's see how can we do it using clustering technique.
Yes.
Clustering technique is example here. It's showing how we can separate out data into 2 types. Let's say initially we are interested in 2 types. So 2 type will create. So what will happen? The algorithm will create 2 random centers, some center value. That because there is no center initially, anywhere there is C1 and C2 considered. Look like this one. There is 2 values C1 and C2.
Right.
And then what will happen? You have to find out from this point all the samples. There is one slide missing here. From this point, C1, if I found, or C1 is here, let's say, and I wanted to find out the distance of each sample. This one, I mean, all the samples. Similarly, C2 is centered is there, and this is another type. So I'll find out. So I ultimately what I'm saying. So I have to find out each sample. Let's say this one, or let's say this one. Distance from this centered and this centered. So we know that this one is closer to this one.
Right.
So that will be marked as blue of this type. So similarly, this is closer to this one, right? C1. So it will be marked as red. So what is happening? Finding the Euclidean distance and then find out the more closer to which one the centroid, the
Right.
sample will be of that type. So then that is done. In that case, what happened? We find out that this many samples belong to C2 and this many are C1.
Yes.
And after that, we have to take a mean of these samples.
Right.
When you do the mean of the samples, we'll come in the center of that. Let's say here. And this also we have to take a mean, and the centroid will move to that position,
Right.
the mean position. That is how the centroid starts moving. So what we did, first we take a default centroid, and after that we calculate the distance of each point from both the centroid. After done, we took the mean, and by the mean of this one, mean of the other one, this one, earlier slide. Mean of this one will be the most centroid C will move. Again, mean of the rate points C1 will move. So that case, the centroid move, and if you see now, once the centroid moves, what happened? Some blue points. These are earlier blue point. These are earlier blue points. Now, because the centroid has moved, the red centroid is more closer. When again the distance you will figure out, each sample again you have to figure out the distance. What will happen? Because they just move in that direction. Some of the samples which are red earlier will be blue.
Yes.
And these are the samples which are blue earlier. Because of the distance is nearer to this, will become the C1 centroid.
So what I understand is that like you take like random centroid points, calculate the distance of each point to those 2 points, find out which one is nearer to which one, and then you group into red and blue, right? For one sample.
Yeah,
Then
grouping means taking the mean.
yeah, and then then the next step what you
Again iteration. So this is the same two states we continuously do.
do?
Again, you do the same thing, finding the distance. After the centroid move, again you have to find the distance of each point in the sample.
No, what I understand is the next time we'll take another random point in the same set, right?
No,
Or
no, no,
it
no,
will be
no random points. First, only
Mhm.
we do the two random points centroids,
Okay,
and then we calculate the distance of each samples from the both centroids.
right,
And then whichever is nearer to these centroids will be marked as blue,
right,
and the other will be marked as red.
right.
Yeah. Then what we did, we take the mean of these blue samples,
Okay.
and that is the centroid now, actual centroid.
Oh, okay,
The earlier one
okay.
was the default.
Default, yes.
That will be random. Anywhere it will be picked in the data set.
Okay. So next you take a mean of the blue and the mean of the red, and then you again calculate the distance.
Again calculate the distance, again take the mean.
Mean, okay.
So these
Got
two
it.
steps continuously repeated, and
Mm-hmm.
after some time, what will happen? Some the samples will be concentrated. The centroids will be going to the middle of that particular,
That sample, yes.
and these will also move to a somewhere point
Point, yeah.
and
Got
middle.
it. Got
Then that time, what will happen?
it.
When you find again the distance, Euclidean distance of each sample, you will see
Mm-hmm.
that all the blue points become closer to blue centroids only. Red becomes closer to red only.
Mm-hmm.
See, after this only, do you see once the centroid, this one is moved to here, this point. So that time, this will be closer, right? All will be closer to this one only.
Right.
So then I cannot say this blue is closer and color it to red.
Yes.
No. And then what will happen? The last centroid, whatever is the center value is their position, and the next one will be the same.
Mm-hmm.
If no samples is going to move, if no samples from red is going to blue or blue is going to red, what will
Right.
happen? The mean of the last this one and the mean of the next will be same, right?
Same, yes.
Because the samples are same only, the same
Right.
calculation. Because there is no movement in the distance. When you calculate the distance, there is no sample that
Mm-hmm.
is transferred from red to blue and blue to red.
Right.
And that is why the centroids will become stable. So at
Stable.
this point, our clustering is done.
So our process is repeated till our centroid becomes stable. Once it becomes
Yes,
stable,
yes.
we get the
Well,
okay.
yes, that is one thing. And other thing is we put a maximum value 1000 like that, so that if it moves very slowly after a certain interval,
Mhm.
so if the value is very less in fractions, very big floating point numbers, we are not care. We don't want it to waste our time in that processing.
Right, right.
So that time, so that's why there is a option is there. You can put the maximum k value,
Okay, okay, got it.
maximum iteration. Sorry, max iterations.
Okay.
Okay, so this is the way, and this is called minimum j.
Mhm.
When distance of C1 read and distance of C2 point plus will be minimum, that is the minimum j.
Okay,
We say.
okay.
Ultimately, the centers has to be stable.
Stable, yes. So once it becomes stable, we have like our clustering done,
Yes. So that is the clustering is done.
and then we can
Yeah,
we
we
can
can
actually
display it. We don't have the accuracy method for that. So we can display it using a 2D or 3D graph.
graph. Okay.
So this is an example of iris dimension only.
Mm-hmm.
One minute.
Okay, sure, take it.
Okay, so we have imported the iris and iris dataset from sklearn, and
Mhm.
so keys is not required. So you can see this. Keys means will give you all the dictionary
Mm-hmm.
key value. I mean data, features, name, and all.
Right.
You can do it. So iris data will be the our features,
Mm-hmm.
and we put in the data frame.
Right.
And the column is the features name, and target is iris target.
Right.
So it's
Right.
mentioned as the target.
So we are doing three clusters here.
So because iris has a three different type flowers, so we put k is equal to 3. Cluster is equal to 3.
Three. Right.
And another underscore clusters is the standard name.
Right.
So k means we put a number of clusters. We cannot put in 2 or 4 because we know there are 3 types are there. And maximum iteration is 1000. After that, it will going to stop.
Sure.
So during this KM objects is returned, then we do feed dot feed. We don't have the y variable. You do notice here
Yes, only X.
only x because target is not there,
Yeah.
and we don't want target. Although its target is there already is there only, but we don't need, and this is not required. The
Mm-hmm.
argument it takes only one, only the
Yeah,
features.
because it is unsupervised, right?
Yeah, unsupervised. It don't need to be trained with target.
Targets, yes.
So we did run the feed methods. So
Mm-hmm.
and so algorithm runs correctly.
Mm-hmm.
And after that, we put this is the, again the standard keyword cluster underscore centers.
Mm-hmm.
So cluster underscore centers will give you
Mm-hmm.
how many centers should be there? 3, right?
Right.
Earlier we have in this document we show 2 centers because of
It will
we
be three,
want
yes.
2 clusters. So here it is
True.
3.
Three.
But
Three centers.
3 clusters will be defined as 3 different rows
Mm-hmm.
and
Okay, got it.
4 columns because every feature has 4 columns, right?
Mm-hmm.
In iris data,
Mm-hmm.
fetal with fetal and fetal with.
Yes.
So the center will also have a 4 coordinates because your data has a 4 columns.
Mm-hmm.
Your data is if it has a, if you see So if you have a like a 3 dimension,
Mm-hmm.
then all the samples if you put, you will have x and y and z, right?
Mm-hmm.
X, y, and z.
Right.
So if I have a any centroid C1, it will also have a coordinate of x1, y1, z1, right?
Right. Right.
And it will C2 if I have centroids x2, y2, and z2,
Mm-hmm.
y2 and z2. So
Mm-hmm.
similarly, if I have a 4 coordinates,
Yes.
then
It
the
will
how
be 4.
many? So x1, y1, z1, or p1, let's say.
Okay. We'll have
In
4
that case,
columns.
there are 4 columns,
But 4 columns, but 3 rows because there are three centers, right?
3 centers. Yeah, that's why
Yeah.
4 columns
The
in
rows will be
the end.
3, but yeah, but basis you have 4 features, it will have 4 columns.
Yes, that's what.
Yes. Okay, got it. 3 centers because 3 clusters and 3 rows and 4
Yeah, yeah,
columns.
you put a 3, that's why.
Yeah, yeah.
And here we put a 3 because we know that there are 3 types of flowers. But we
Mm-hmm.
don't know, we didn't train with the name of the flowers.
Okay. So one question that like it shows these values, right? What does these values mean? Like for example, like 5.9016129, the first number. What does that mean for the
That is
first?
the mean is what is the x distance?
Okay.
X, Y, Z, and
The fourth coordinate.
this is the coordinates only.
Okay, okay. So it is telling me that the centroid is
Let's say this
5.96.
one only. So it is x distance is this much,
Mm-hmm.
y distance is this much,
Right.
and z distance is
This one.
whatever is z is in which direction I say it. Yeah. So whatever it is in, it will be coming in front, right? If
Mm-hmm.
it is x, y, z, it will come up like this way.
Mm-hmm.
So it will come in somewhere in, let's say, this distance.
Mm-hmm.
If you imagine, because this will be not an x and y plane, if it is a z plane, it will come out, right?
Mm-hmm.
It will come out in this direction, right?
Right.
So that distance is z.
Okay. So all these four, the four values are showing me the coordinate distance from the respective axis
Yeah, respective axis.
for that particular centroid.
Yes, particular centroids.
Okay.
It's open here only. So this is km underscore labels. Labels means so it has specified as a tree type, right? So
Mm-hmm.
we didn't specify any value,
Mm-hmm.
but it able to find out there is a 3 types by the clusters, means one type, other type, or other type.
Okay.
So that it has put a label as 1, 0, and 2,
Two.
non-based on training by randomly. Then what it means that all ones should be one only,
Okay.
because it has grouped a similar data in one place.
Yes. Okay.
So in that case, all ones should come together.
Mm-hmm.
All zeros should be come together.
And what are these one and zeros representing in the Irish data set?
No, that doesn't mean anything. If I have to, if I don't know the name of red rose as red rose,
Mm-hmm.
I have a machine and I don't know one is called a red rose, one is called yellow rose, and one is called a white rose. So as a machine, I say that only 0 or 1. Just put it red rose. I put
Oh,
okay, it is a
okay.
0.
Okay. Okay. Got it.
Yeah. So it can as well as it can put the 0 also and 2 also, any numbers.
Okay. Okay.
But all one type should be of one
Mm-hmm.
digits. Again, all 0 should be 0 only, but there is some 2 is there in between. So
Mm-hmm.
this is a wrong calculation. I mean, it's a wrong. I mean,
Level.
clustering. Actually, this is a type of, let's say, 2, but it's coming here.
Yeah, yeah.
So it is a the clustering is wrong. So another samples comes in here. So similarly, you can see here if all should be 2. In between there is 0 is there.
Mm-hmm.
These are again wrong.
Okay.
So that if you put it
Mm-hmm.
predicted level and actual level. So this is we already have a target, right? Given this sample, but we have
Yeah.
not used it in our problem.
Problem. Yes.
So we got a label as 11111, and in the machine we have
That's
supplied it like this 00000 like this.
yeah.
So that doesn't matter that is 0 and is 1 because we have not trained with saying that if this is a features,
Make it one.
we have not
Yeah.
trained with that target for this
Yeah.
row.
Mm-hmm.
So it's all good if I say getting all 1 instead of 0.
That's fine.
If I
Okay.
get any other numbers, it's wrong.
Okay.
Understood, right?
Yeah, yeah. Because since like in like supervised learning we provide that target,
Ah,
and so that's why we predict we can do a comparison. But here it's we don't provide any target, so it's
right.
okay to have a different number. But if like you have a different number, like for instead of 0, if the other ones are all 1 and then in between it has like 3 or 2, then it is wrong, right?
Yes, yes.
Okay.
So the problem is, yeah, the same thing is printed out is there. So I will send you, and
Mm-hmm.
I will show you the graph if it is there. You can. The thing is that you can apply a graph. So
Yeah.
I should have many examples with graph and what I
Okay.
first. It's a Titanic data set. Okay. Maybe I tried some Kmeans and Titanic data set also. You can try the same data set with different problem.
Different problem. Okay.
So what it is basically doing. Based on that, there is a survive dead or alive. We put two clusters. Can you see there?
Yeah.
That because it's a survivability problem, so we have two predictions.
Mm-hmm.
So we wanted to solve it using clusters.
Just to see.
Okay, so you can check out this problem, but I don't think so. So there is some informative piece there. So main thing is that I wanted to show you how to put a graph on it.
Yeah.
And so there is a system change in between. So that time I think some samples are four
Yeah.
samples remain with me.
Hmm.
It's too heavy face, not getting open notes. Not this one, it's 2 dimensions, so I will put it 3 dimension.
Right.
Somewhere it is nicely explained, so the syntax is a little bit difficult, so I don't remember. So
Right.
I'm not able to find that one. Exactly, I will send the result to 3D. So I will check and I will send you.
Okay.
In the next class, let me check on this article. Maybe here it is. I remember like this.
Right. If it is not there, you can check it and you can send me later.
Yeah, this one is here.
This one, okay.
So this is the sample. We don't need to create a sample already we have the data.
Right.
So it created not this one. So let's say we have what it is. We have 4 features, right? This is the first features and second features into.
Right.
That is because of in the 2D plan you wanted to.
Mm-hmm.
You wanted to say that I show you that centers have a 4 coordinates, right?
Mm-hmm.
So we cannot see the 4 coordinates. So here it is showing in 2 coordinates.
Right.
Y which is what?
The predicted value.
Yeah, the K is the predicted value on the X.
Mm-hmm.
So predicted. So YB is and if you see this one is once again, C is the black. So yes, this one is the centroids. So this scatter plot is created for creating the 4 centroids.
Centroids, yeah.
This CMAP and value with this one indicates different colors it will create.
Okay,
So
got it.
it has a different parameters like that. So which are
Right.
something default. and the sample is the size. So if
50.
you ask equal to 50, it will be smaller, and 200 you put, you get bigger circle, right?
Right.
And I put so here it's put it in the black. So this way we can create a cluster on it. So
Yeah.
this tree line.
Mm-hmm.
So what you can do, I will give it a code already there. So you can put this one on the two axis. After creating this, so you can try to create this one.
Okay.
See if you can do it by yourself.
Okay. Sure.
So what will be requiring you? Like I have already opened, I think. It's cluster. So Kmeans may require you to clustering may require you to go on this one, put in the presentation because you don't have the accuracy value, right?
Mm-hmm.
It's already there, already created.
Okay.
I didn't put it. So it's already put it here. So you can use it directly.
Okay.
So here it
So
is.
it's already part of that thing, right?
Yeah. Already I keep it here. I thought I missed it.
Okay.
So up to here, if you have seen that with the explanation. So after that, so how many x is what? See, we have target. So km underscore levels up till here we have did, right. So after that,
Yeah.
df predict columns we created here out of the levels. This one of
Levels.
km levels.
Mm-hmm.
So this is again a hard coding value, right? So for inbuilt value, sorry, inbuilt variable. So y means is km dot predict on x.
So the labels has been predicted by our algorithm, right? The Kmeans
Yeah.
algorithm. Yeah.
Yes. Labels has been created by km algorithm.
Yes.
And then you have to put centers is equal to
Mm-hmm.
cluster centers. So
Yes.
out of that also four coordinates are there. So we have to keep two only.
Two only. Yes.
Otherwise we cannot display it.
Yeah.
So X is the data, right?
Mm-hmm.
So X is the iris data. Directly from the data, it created that one down.
Mm-hmm.
So if it is, if you see this one, X L run on. Clustering can be used for bigger problem also.
Okay.
Yeah, check if it is a medical data or something. When you
Mm-hmm.
wanted to find out anatomy or something, say in the
Mm-hmm.
cancer cell, all cells should be good, and how it's a cancer cell should be look like.
Okay.
So this is the X. X is the data.
Mm-hmm.
I the data this one. So for this data, we did it here.
Mm-hmm.
0 and 1, right?
Mm-hmm.
First to row, again first to row only.
Right.
So it is not printing this time. It will print.
Yeah. You did.
So okay, then I will give it to this document now. You.
Okay, that's fine.
Yeah. At the moment, there are 5 minutes. If I start something new, then something will be left. Or
Yeah, yeah, sure. So, so on Monday, can we start at 3:45?
school started, right? For you?
No, yeah, 3:45.
Yeah, yeah.
On Monday.
Children's school was started. Something.
Yeah, yeah, children's schools are starting. Yes.
Yeah, yeah, yeah. Sure, sure. That is again a big, yeah. You cannot help
Yeah,
all these things.
yeah.
So in the
It's
US,
like
there is no, I mean, bus facility or something. Children's are
no,
small.
no, no, no. It has, but the thing is, like, I have to make sure the kids get up, they get ready, and all those things. Because like then they can go in the bus. But like before that, they have to get ready, shower, eat breakfast, everything.
Okay, okay. That time is coming in for right. Like for
Yeah,
me,
yeah,
it's 7 p.m. Yeah.
yeah. For them, like they will start like around like the school starts around like 8:30. Yeah.
Okay.
So that's why like that 15 minutes earlier, if we finish, that gives me a big jump. So on Monday, like what topic we will cover?
Yeah. So K means clustering. We'll be covering starting on naive Bayes theory. Naive Bayes theorem.
Bias theorem. Okay, got it. Okay, okay.
So naive
So
Bayes, if
that's.
you can, naive Bayes has a tree. It can solve
Mm-hmm.
three things. It can work on text also.
Mm-hmm.
It can text also and binary classification also and general classification. So we'll be seeing general class. I mean multi-classification as well as text classification.
Okay.
After that, again, time permits, then we start on PCA.
Okay. Okay. That's fine.
Okay.
Okay.
So, I mean, you are, I mean, going to pay the rest in next week, right?
Yeah. By next Thursday, my parents are coming back.
Oh,
So hopefully by Friday, I should be they should be able to send the money.
okay, fine. Okay.
Okay.
So after
Okay.
that, yeah. After that, I mean, I'm just going to share you right now all these things.
Yeah. Yeah.
Okay. Good, happy weekend. So, see you.
Okay. Okay.
Yeah. So
Okay.
things are
Thank you
clear,
so.
right? Till now, whatever is done, it's helpful.
Yeah. 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 And I will try to refresh also like today's topic and the previous one this
Yeah.
weekend.
So what is the
Uh,
time required actually? The concepts to bring it in our mind actually
yeah.
that if you don't do repeatedly, I mean, it seems to be forgot and not comfortable.
Yes. Yes. Exactly. So you have to always keep on going back because it's a new topic, right?
Yeah.
For me. So it's like I have to constantly refresh
Yeah.
again.
Otherwise, today if you understood also, after 1 week, it will go out of the mind.
So my
Think of it,
exactly.
the brain will not keep on remembering that.
Yes, yes, yes.
Okay, then see you.
See you. Okay, see you on Monday,
Yeah.
3:45. Okay,
Yeah.
thank you.
3:40.
Bye.
Bye.